Hello, students. Just wait for 1 minute. We can start. Okay. Students are still joining. We'll just wait for another 30 seconds or 1 minute. We can start. I hope like my screen is visible to you already. Yes. Anyone just give me a confirmation? Okay, fine. So actually, we have designed our own app, own website now. So previously there was a problem of a video quality, like the quality of the video was not that good. So that is why we have shifted the platform from aggregated app to this website. So I just wanted to test it, like how it goes. So that is why I'm just taking the class in this particular website now. If you face any problem, so just text me in this chat box, or you can also unmute yourself directly and answer me. Okay, anything is fine. I see some new names today. Krishna, Rahul, okay, Uma. This is your first class, and this is my last class. If it is your first class, but this is my last class of this technology. Okay. So in the meanwhile, I'll just discuss like what we have discussed till now. Okay, in the C technology, what all we have discussed and what we are going to discuss today. So when we talk of seed technology, we started our discussion from floral biology. Once we finished the floral biology, and we talked about the few aspects of seed physiology and the seed development, how it happens, and the enzymes that are required, and the growth promoters or the growth regulators or the hormones which are responsible for the growth and development, and how it impacts the different stages of the cell cycle. So that we have discussed. After seed physiology, we started our discussion about seed legislation, and we completed the legislation, and then we started the discussing seed certifications. So in the meanwhile, I told you all the different policies starting from the Seed Act 1966 to the latest Seed Bill 2019. Right. So these are the things that we have discussed in the seed legislation, and I also talked about the protection of the plant varieties and the farmers' right. Next, we talked about the seed certification, how the seed certification is done in India, and how it has started, and what are the different organizations that are involved, and what are the certain procedures that are needed to be followed in order to certify your seeds in India. And we have talked about one important institute, that which is the International Institute, that is OECD, which look after the certification of 7 categories of crops. Right. So this was still seed certification. So after certification, then we dealt with the seed production. What are the important things? I told you what are the things to be remembered. The things to be remembered is about the pollination biology, the isolation distance, and the number of field inspections, and if there are any cultural practices, and planting ratio, and what else, like the germination percentage, purity percentage, and genetic purity percentage, and what else, designated diseases, designated weed species, and the seed multiplication ratio. So all these things are very much important in case of seed production, so that we have to remember. So apart from that, next we have I just left out the most important thing, which is tag color and tag size. So this is the one of the mandatory questions that they will ask in one or the other year, like one or the alternative year, they will definitely ask this particular question. So just don't make any mistake in that particular question if it is asked in the exam. Okay. So after seed production, I dealt with post harvest operations, where we started our discussions from seed harvesting, after harvesting the threshing, seed extraction, whether it is dry extraction or the wet extraction. When the extraction is done, it's about seed packaging, and next it's a seed drying, storage, like drying, packaging, storage. Once the seeds are stored, then it's about seed testing now. So now in today's class, we are going to deal with seed testing. So till yesterday, we have talked about seed storage. So once the storage is successfully done, it has to be tested before they are certified. So only after the successful testing, if they are meeting the prescribed standards, only then they are eligible for certification. So what are the different parameters that are looked during seed testing that we'll look in the today's class? Okay, and also the different methods that are available for testing the different parameter seed quality attributes are the parameters. So before this class, you might be very much confused about the different methods of seed testing. We have like cold test, cool test, GADA test, and also radical emergence test, electrical conductivity test. So we have so many methods of seed testing, but the major thing, like most common thing that we lack is understanding like what for what purpose these tests are done, like what are the categories under which these tests will come. So in today's class, I will try to make it very clear for you so that you won't be confused. It's not just a mug up that you will do from today onwards. You will just understand in which categories of the seed testing we'll get these methods. Okay, so that will look in this today's class. So before starting our discussion about seed testing, we'll talk about the history of seed testing. So how it started and where it was initially started, and what are the different institutes or the organizations that were established. Okay, this was just a brief overview of what we are discussing today. So let me talk of outline. So in the content outline, today we are going to discuss the objectives of seed testings, why the seed testing is necessary, and world history of seed testing, Indian history, and what are the principles of seed testing. And next we'll talk about the seed sampling. Seed sampling is the way, well, once the seed testing is started, it starts from seed sampling. This is a step. This is the first and foremost important step in the seed testing, where the sampling is done, and then the samples are sent to the seed testing laboratory where the testing is conducted. So these are the content that we are going to discuss today. Talking about the objectives of seed testings. Why do we require seed testing? As I already told you, first and foremost important thing, to determine the quality and their suitability, whether they are suitable for planting or not. This is the first and foremost objective of the seed testing. Then to determine the seed quality problems. If there are any problems in the seed quality, that we can identify by seed testing. And also to determine whether it requires drying, processing, or specific procedures if it's necessary. Only after seed testing will we get to know if there are any mechanical mixture, or if they are genetically deteriorated, or if the moisture content is too high. Only then we can take some precautions so that it won't deteriorate the quality of the seeds. So this is one of the objectives. Next, the seed, to determine the seed meets the established quality standards, and this is very much important for both certification and labeling. Since according to the Seed Control Order 1983, whatever seeds that are sold in the market that are to be compulsory labeled. So seed testing also becomes very much important for the labeling part, even the farmers or the seed producer if he is not going for certification. Next, to establish the quality and provide the basis for the price so that it will attract the consumers in the market. So what is seed testing at the first place? It's just a science of evaluating the planting value to achieve the following objectives. So what are the following objectives? So I told you, right? So next is about the history of seed testing. So where it started. Where was the first time it was started, the seed testing? So what is the history of it? So during 19th century, as the people got to know about the importance of the seed quality, they started the seed certifications. So apart from the seed certification, in the parallel side, the seed testing was also recognized, where it came to know that we can only assess the quality of the seeds by testing the seeds. So that came to know in the same 19th century. So this was actually seed testing concept came to prevent, like it was just to prevent the surplus practices that were prevalent in seed trade. So the seed trade was actually rising, or it was in the growth phase during the 19th century, where because of knowing the importance of the quality seeds, actually everyone were replacing their farms save seeds to the quality seeds from the market. So during this period of seed trade, there was very much illegal activities that were taking place, where no one was maintaining the quality of seeds. For this sake, the seed testing was organized. Like this, for this particular reason, the seed testing was organized in 19th century. So it was in the 1869, for the first time, the first seed testing station was established in Germany. It was in the place called Trident, Saxony. So can anyone tell me like who established this particular seed testing station? It was in Germany. Okay. So the first seed testing station was established in case of Germany under the direction of Friedrich Nobel. You people might have heard this name. He is the father of seed testing, and it was in 1869. The first seed testing station was established. So try to remember this point. So next, it was in 1871. The seed testing lab was opened in Copenhagen in case of Denmark, and this was by the direction of E. Moller Ost. So after that, it is in the 1876, Nobel's classic treatise was released, and with the title Handbook of Seed Testing. He wrote a classic treatise with the name of Handbook of Seed Testing in 1876. So next, later in the later part, in the same year, the first seed testing lab was established in the USA. And later in 1897, there was a first publication of rules and apparatus for seed testing. So before that, there were no proper procedures for seed testing. Only after 1897, there was a first time there was a publication of rules and apparatus for the seed testing. And this was by United States Department of Agriculture. Okay. And we have like 1915, 1916, 1917, there were different scientists who discovered the seed divider, seed counter, and seed blower. So we'll discuss seed divider in bit detail, since it is very much necessary for seed sampling to take place, or to do the seed sampling, it is very much important. So we'll discuss in this particular thing in little detail. And also market, this is very important. They will ask some direct questions from the seed divider. So knowing the importance, like since the seed testing, okay, now the seed testing labs are already established, there are certain procedures for it. So for the international trade to happen, there needs to be standardization of the procedure, because there are several procedures that are followed to test the seeds, but they were not uniform throughout the world. So the results of those tests cannot be compared as such. Since the procedure itself is different, how can we compare the results of two different tests? So this required the standardization of the seed testing methods. Which one to standardize, which test is most accurate? So because of for this reason, there was need for standardization, which led to the formation of organization in 1908, which was called as AOSA. AOSA is nothing but Association of Official Seed Analysts. This was called as Official Seed Analysts of North America, and later it was in 1939, it was changed to just AOSA, that is Official Association of Official Seed Analysts. So what are the objectives of this particular institute or the organization? The basic objective of the AOSA is to develop, adopt, publish rules, the common rules for the seed testing, and to encourage the research in the seed technology. And this will meet annually, and the rules are actually updated every 5 years, for every 5 years. Next, we have another organization or institute which is called as Society of Commercial Seed Analysts, and this was formulated in 1922 in the USA and Canada. And this was for the similar reason, where to maintain the high professional standards of the members of this USA and Canada, where to it will promote the best interest of seed industry, and it will also encourage the cooperation between official seed analysts and the private sector. So this was done only to encourage the seed business in that particular area. So as I told you before, that as the seed testing procedures developed, there was a strong need for the cooperations between the different countries for framing the seed testing rules. And also, if the seed is moving in the international trade, it should have some label on it, or it should have some certificate on it, which is recognized by all the countries throughout the world. If it is not recognized by major countries, then during the international trade, if we are exporting some seeds to the foreign countries, like it's up to them whether they will accept the seeds or not. If the procedures that we follow in India to test the seeds, they might not accept that particular method. They will have their own methods of seed testing, but as such, they cannot compare their results with our results, since in the first place the tests are already different, right? So for this purpose, there was a need for establishment of international organization which will keep up the interest of all the member countries, and it will provide the uniformity in case of seed testing, which will bring the uniformity in case of seed testing. So this was the first objective, and second was to provide the certificate so that there won't be any problem for the seeds that are moving in the international trade. So for this particular reason, one institute was established. So can anyone tell me, can anyone name the institute? What was the name of the institute which is related to seed testing? It is called as ISTA, International Seed Testing Association, and it was established in 1924. So headquarters of this ISTA is located in Zurich, that is in Switzerland. So this is a international institute in which the India is also a member, where it will provide two different certificates, which is called as blue and orange. These are the two different certificates. Blue is for just for the seed sample, and orange is for complete seed lot. So the seed lot certificate is of orange color, seed sample certificate is of blue color. So these two certificates are provided by ISTA. So remember this particular point. Okay. So what is the objective? I told you the objective of ISTA. The objective is to develop, adopt, publish the standard procedure for sampling and testing, so that it would be uniform throughout the world. And also it's as the objective to promote the uniform application of them, like application of the test for the evaluation of the seeds which are moving in the international trade. Right. So it was in 1955 where it opened the membership for the private companies. Okay, it's not just India, like it's not just a country that will become member of this ISTA. It's an organization which can have the membership of these particular organizations. For example, if we have certain seed testing laboratory in India, that can become a member or take the accreditation from the ISTA, so that if we go and test our seed in that particular lab in India, they have the authority or they have the power to give or provide the international certificates, which are seed sample certificate and or seed lot certificate. For that to happen, it has to be recognized by the ISTA. So that is what membership means. It is not limited to country. Okay, it's not the country wise, it's about that seed testing laboratories, where it will just come and recognize. If it is self-sufficient in providing the better results, then they will give the accreditation. Based on the once accreditation is provided, seed testing laboratory has a power to provide the certificates which are orange and blue. So this particular organization has 20 technical committees, and the validity of the accreditation that is provided by the ISTA is for 3 years, and it will be renewed from there on. So this was in a seed testing conference where the ISTA was established. So there were total of 4 conferences that was held. There are other later after 1924 also, like there were other conferences like a seed testing congress that were held. But this is until the establishment of ISTA I've written here. So the first one was in Hamburg, and it was in the Cambridge, UK, where the ISTA was established. It's not the place, but it is in the conference. It is in this conference, which was held at Cambridge, the ISTA was established in case of 1924. So what is the full form of ISTA? It's International Seed Testing Association. So this was about the word history of seed testing. I hope like it's very easy and convenient for you people to understand and to revise the things, since I have just come up with a proper chronological order. I hope like this will bring up this will be easy for you people to understand and remember the things, right? So next we will just deal with the Indian seed testing history. So where this proper seed testing begin with the establishment of 4 seed testing lab, where the first seed testing lab was the Central Seed Testing Lab, which was established in 1960. So I just written the information where it was in 1955, the decision was made, and 1958 it was established, and the proper functioning started from 1960. So this can be important. Like Rockefeller Foundations provided the funding for the establishment of CSTL in India. So this is Central Seed Testing Laboratory. So this is the one and the same where we talked about the referee testing. So in order to keep up the interest of the seed analyst and to keep up the interest of the public, the referee testing is done with the 5% samples that are needed to be sent to this Central Seed Testing Laboratory from all other labs located in India, right? So this is what we have discussed. So this is the same Central Seed Testing Laboratory which I was talking about. So this was established in IARI, New Delhi, but in later period, it was transferred to NSRTC. So it was in 2007, it was shifted to Varanasi, NSRTC. And it was in 2005, the NSRTC was established, and this is in Varanasi, UP. Okay, and the other seed testing like labs that were established was in the Hyderabad, Ludhiana, and Patna. Now we have around 167 seed testing laboratories. like notified seed testing laboratories that are located in India. Okay, they might not ask you the exact figure of this particular thing, but it's just for your knowledge. So what about central seed testing laboratories? So how many central seed testing laboratories are there in India? So if they ask you like this question, it's two. There are two central seed testing laboratories in India. One is located in NSRTC, which I told you. What is the full form of NSRTC? National Seed Research and Training Center. Okay. The second one is located at CICR, Nagpur. So can anyone tell me like what is the full form of CICR? Yes, what is the full form of CICR? Yes, you people should answer this because I already given the location of this CICR. Yes, very good. Central Institute of Cotton Research. It is located in Nagpur, and this is for GM testing, or this testing the GM cotton. So this is about the two central seed testing laboratories that are located in India. So talking about the ISTA history, or like talking about the ISTA, coming back to ISTA. So there are total of 16 members countries, like member laboratories in India, and out of which, other than these members, there are total of 8 ISTA aggregated labs. So where these 8 labs have the power to provide the seed lot and seed sample certificate. So where are these 8 laboratories located? So this Namdari, Indo-American, Mayako, East West, Kalash, Nuzivedu, Telangana State Seed Lab, and lastly it's Coimbatore. So out of these 8, 7 are private and 1 is government, which is located in Tamil Nadu, Coimbatore. So these are the stats for the ISTA accredited laboratories and the ISTA members. Okay, so management of seed testing work, how it is done in India. So management of seed testing work starts with the receipt and registration of the seed sample. Once the seed sample are brought to the lab, their registration is done. Once after the registration, moisture test will be the first one to do without any delay, and they will prepare the working samples based on the tests that are needed to be done. And it is very important to know that you might ask me the question like, where there are so many different tests and there are so many different parameters. So parameters, I mean, it's a germination test, physical purity test, vigor test, viability test, moisture test, cross test for other crop seeds, ODV test, and genetic purity test. So these are all the different seed health tests. So these are all the tests that are available. So out of, for all these parameters, for how many parameters does this seed testing laboratories will do regularly? Like for what parameters does they conduct the test regularly? So it is called as a routine test, where the 4 different tests are followed, which is germination test, physical purity test. It's not just purity, it's physical purity, and test for other crop seeds, and lastly it's moisture test. So moisture test is by the hot air woven method. So this is a standardized method from the ISTA. ISTA recommends the hot air woven method for testing the moisture content in the seed testing laboratories. So we have several other moisture testing machines or moisture testing methods, where we use the electronic machines or digital machines are already available now, where immediately we get the results. But still, the hot air woven method is the one which is recognized by the ISTA or recommended by the ISTA. Right. So germination test, what are the different types? We'll discuss in detail in the upcoming slides. So, and also when the test for disease seeds is, or the other variety is required, or it is asked by the farmer or the seed certification officer. So this will be done. This will be also included in the routine test. But basically, routine tests include only 4 different tests, which are germination test, physical purity test, test for other crop seeds, and moisture test. And the reporting of the test results should be done within the 21 days after the receipt of application. And there should be a guard sample which would be kept for at least 1 year from the date of issue of report. From the date of issuing of the report of the seed testing, once it is done by the seed analyst, it is their duty of the seed testing laboratory to keep the record for at least 1 year. So next, it's about sampling. So how do we do the sampling? So we just stopped our discussion till seed storage. Once the seeds are stored in the godown, So this is how it looks. They are stacked one above the other in case of storage godowns. So this stacking, so the seed lot, the seed samples are taken from it. The samples which are derived from this seed lot are called as primary samples. So once the primary samples are taken at random from all this from a complete seed lot, it is mixed and it is formed a composite sample. So once the composite sample is formed, from that composite sample, certain fraction is taken and which is given as submitted sample. So once this is given to the seed testing laboratories, submitted sample, so based on the number of tests that are required to be done, they will divide the working sample for each test. Okay, from the submitted sample, they will derive the working sample for the each test. So this is how it is done. So I just asked you or posted one important question regarding number of primary samples that are needed to be taken. So I think one or two of you have answered this in the group, but none of you have asked me the explanation for the same. Like why you people forget about it? Because this is also very important thing, because you might also expect this question in one or the alternative year. They will definitely ask about the table. There is a fixed table already. Based on that, they will ask you directly what are the number of primary samples that are needed to be taken if the seed lot size is this much, whether it is in the container or it is in the bag or in the bulk. So we'll just discuss it separately in the next class. Okay, I'll just take one more class. I'll just simply conclude, take the questions of this seed lot, and I will conclude like what are the things to be delivered. Okay. So coming back to the sampling. The sampling is done to get the representative samples of a size which are suitable for set testing. So if we just go through the types of the samples, it is a primary samples which is then clubbed together to form the composite sample. So from this composite sample, there is a submitted sample which will be sent to the seed testing laboratory. So these are the three different methods, like the three different types of the samples. So how the sampling is done now? The sampling is usually done by using the triers. The triers, we have two different types. One is stick or sleeve trier, and we have no bed triers. So this is how it looks. It's a steel rod. It is a solid rod which is with some indents in between and the sharp edge. So this is the sleek or stick trier. So the exception to the use of this particular trier is chaffee seeds. If there are chaffee seeds in the seed lot, we cannot use this particular method. So next we have an obey trier. I hope like you are very much familiar with particular this trier. So this is how it is done. Like this is suitable for the seeds which are in bags, not in the bulk. If they are in the bags of this kind, they are suitable for sampling. And then we have a bin sampler. So this is a sampling in case of godowns, like sampling in not in case of when the seeds are heaped in the godowns. So this particular sampling procedure is employed, and this is seen in the maize bin sampler. So sampling is done by bins, like it is also called as bin inspection or bin sampling. So this is for maize. And we have also sampling by hand. So this is how it is done, and this is for the chaffee and non-free flowing seeds. For the sticky and chaffee seeds, so sampling is generally done by the hand. So you can just clearly see the figure, how the triers are inserted to the bags and how the samples are recovered from it. So this is how the this is a collection of primary sample from where the different number of bags, the number of bags that will be sampled will be fixed. So though in those bags, the sample will be removed by inserting these triers. So next, once the samples are collected, we have to divide, or we have to mix and divide the samples. So if we do not do this particular procedure, then there will be a heterogeneity in the seed lot. So that is why this particular mixing and dividing the seeds is very much necessary, so that whatever the samples that we are taking, it is the representative of seed sample. It's not a one part of a total seed lot. It is just representative of the seed lot. This only occurs when we just do the thorough mixing and then we divide it. So what are the methods of mixing and dividing? We can divide it through mechanically, and also we can use the random cup methods. We have modified halving method and spoon method and halving method. Just go through the text once. So I was talking about the divider, right? So how the dividing is done. So the methods for dividing is mechanical divider method, which consists of Bornier dividers and gamete divider. So the gamete dividers employs the principle of centrifugal force. Bonnier dividers employs the principle of gravitational force. So this will be very much important. Just try to remember it. So this is a Bonnier divider and this is a gamete divider. So and it is also called as conical divider. And also try to remember the other names. There are certain other methods. You just go through them once, but there is nothing to remember, nothing to be remembered from this particular paragraph. But at least you should know that these are the methods of mixing and dividing the seeds. So this is just an halving. This half how the samples are halved, and then the representative or submit the working sample is taken from it. And we have a spoon method, which is also used for taking the samples. Next, we have we have also the seed soil divider. This is also a type of dividing machine where it is called as riffle type soil divider, and this is how it looks like, and the tray and the bin. This was regarding the sampling. Okay, we just talked about the sampling. Now we have the handful of samples which are ready for the testing. So what are the different tests that are employed? So the test includes the physical purity, GOT, like genuineness of varieties or genetic purity test, where we use specifically GOT for that. And we have germination, seed viability, vigor, moisture, and seed health testing. So these are the different tests that are to be done. These are the different parameters for which testing is done in the seed testing laboratory. And unofficially or informally, the seed vigor test is also done by the farmers before they sow the seeds to know the ability of the seeds, whether they will germinate or not. It is not only the thing that it is done in the laboratory, it is also done in the traditional method, through the traditional methods also. So I have one question. You can just answer this question before we go further. Okay, Arth is answering it as 3. Okay, everyone is answering it as 3. So who gave this brick level test? And what is the common method of viability test that is followed in? Someone said something?
Sir, is it Hilton who did the level test?
You're saying it as Hiltner? Nanika?
Yes, Hilton.
Yeah, okay, fine. Good. So this particular test was developed by the Hiltner. So what about the viability test? Which is the viability test that is followed for checking the viability of the seed?
It's a tetrazolium test.
Yes, it is tetrazolium test. It is a test, and this was given by Lacon. Okay, so the growth test is nothing but a genetic purity test. I hope this is very much simple to answer, right? So next we'll start our discussion about the seed purity test or physical purity test. So working sample. So first and foremost important thing, just remember that the minimum sample size is 2500 seeds with the maximum of 1000 grams. It cannot exceed 1000 grams at any cost. Whether it is the seeds can be decreased, the size of a seeds can be decreased, or number of seeds can be decreased, but it should have the maximum of 1000 grams. So this testing of seed purity is just a table examination where the samples are separated into 3 major fractions. One is pure seed. So there are certain procedures like how to consider it as a pure seed and how to consider it as other crop species, but you need not to worry about it. But at least know that they are generally divided into 3 different fractions, and based on the number of seeds in the pure seed fraction, the percentage of pure seed is calculated. For example, if there are 100 seeds, total of 100 seeds, out of which the pure seed number is 98, and the inert matter number is 1, and seeds of other crop seeds is 1. So in this case, what is the purity percentage? It is 98. And it is considered as a superior, the quality of a seed is considered superior if the pure seed percentage is more than 98%. And there is a formula for calculating the pure, like percentage of pure live seed, which is germination into physical purity. Out of these 98 pure seeds, how many are actually live? So that is by that we can know by the germination percentage, right? So just by crossing this, like multiplying this germination percentage and the purity, we'll get to know the percentage of pure live seed, which are pure and simultaneously live. So this is the formula. So there are again other special tests, you know, to worry about it. Secondly, we have genuineness of varieties, which is also called as genetic purity test or varietal purity test. So how, just remember the sample size, working sample, it is done on the 100 seeds in 4 replications, which is 400 seeds. For 400 seeds, it is done where 100 seed into, it is divided into 100 seeds with the 4 replications. So this particular genuineness of varieties is carried out in the 3 different ways. One is table examination, like lab examination. Second one is a greenhouse or growth chamber examination, or field plot test. Field plot test or field inspection is nothing but GOTA. So in this particular slide, most of the confusions will be clear. So these are all the tests which belong to the genetic purity test. If I just directly come and ask you, like, okay, what is collaborative test and why we do it? So you might not able to answer it, like why it is done and what is the objective of it and under which category it comes. But from after seeing this slide, you will be able to answer that. See, if in the lab examination itself, we have certain categories where in the lab examination, we examine the seed, or either we examine the seedlings, and we also have certain chemical tests where the chemicals are used, and we have the biochemical test. Clear? So in the examination of the seeds, this is basically done on the morphological traits. So this is very much similar to ODV, that is determination of like other distinguishable varieties, how it is done in the similar manner, where in the table examination is done, where for the stable morphological characters, the seed is checked. So if there are any deviation, then it is considered as off type. And for this purpose, scanning electron microscope is used, which will differentiate based on the differences in seed coat, like not only the seed coat structures, for all those different morphological structure on the seed. Next, we have the examination of the seedling, and this is particular for some certain specific crops. For example, coleoptile color test is common for cereals, avocatal test is common for beta species, cotyledony test is common for brassica, and lastly, there is a fluorescence test which is limited to lolium and festuca. So you should be able to remember this particular thing, where which test is specific to which crop. So this is the important thing to remember. So next we have the chemical test, which starts with the phenol color reaction, which is very specific to the wheat. And only in the wheat we are able to distinguish the variety based on the phenol color reaction. Next we have a seed peroxidase test in the case of soybean based on the enzyme activity. Then we have the KOH bleach test in the sorghum, ferrous sulfate reaction, paddy, and NaOH or potassium permanganate test in case of pea and wheat, and alkali test for lupins. So all these tests, why do we do it? To distinguish the varieties, or to identify, like calculate the genetic purity of the seed lot. Next, there are the biochemical test, which employs the electrophoresis. There are again different types, where it is Utleaf phase, acid phase, and STS phase. Not to worry about the examples here, this is not important, but at least know it. So what is Utleaf? Utleaf is nothing but the ultra thin layer isoelectric focusing. So phase, I hope like you people already know it. Since you have idea about the electrophoresis, they will be having the some idea about the polyacrylamide gel electrophoresis. STS is the use of the sodium rhodocyl sulfate for electrophoresis. And the next is using of acid. So as I told you earlier, this is just a repetition where I'm just repeatedly telling you that in India, for genetic purity testing, certification is genetic purity for certification is mandatory for only for the hybrids of certain crops, which is cotton, muskmelon, castor, true potato seeds, tomato, and brinjal. Okay, so this was the question which was asked in, I think, 2022 paper. So just take your time and try to answer this question. Meanwhile, I will be back. Yes, anyone got the answer? This is not the SRF question, this is the JRF question.
Sir, 2000.
Okay, how it is 2000?
So there is a chart like if 0.5% permissible limit is maximum, then how many seeds should be tested? Like there was written.
You have seen the table. Okay, database. Okay, I'll just tell you the one easy things how you can remember this particular maximum limit. So if you just want to remember it, not to understand like how it is, you can just remember from this particular table, where it is directly known that if it is off types are 0.2%, it's 2000 plants that are need to be observed. If it is 0.1%, it is 4000 plants that are needed to be observed. But in order to calculate that how many plants are to be observed, how it is fixed, we have a formula. Formula is according to the E star, number of plants for genetic purity testing must be always equal to 4 into n, where n is the total number of plants to detect one off type. Okay, so what I mean to say is, for example, we have 0.2% off type. So 0.2% is nothing but 0.2 in 100 or 2 in 1000. So at least we require 1000 plants to identify the two off types. So total population should be at least consist of 1000 plants to identify two off types. So what about one off type? One off type can be identified with the minimum population of 500 plants, right? So there it requires 500 plants to observe at least one off type. So this is from the 0.2% that which I have decoded here, right? So as I told you, it should be always equal to 4n, where n is now 500, which equals to 4 into 5, which is 2000. So whenever it is 0.2%, you have to observe 2000 plants. So we can also take the other examples, not only 0.2%. Well, let us take as 0.1% now. If it is 0.1%, so 0.1% is nothing but 0.1 in 100, right? So 0.1 in 100 is nothing but 1 in 1000. So now what is the value of n? N is equal to 1000. So what is the value of 4n now? It is 4000. So if we have the permissible limit is 0.1%, then we have to observe 4000 plants. Let us check it. Is it clear? So see, the 0.1% it is 4000. If it is clear, I need a reply from everyone. Just chat in Just type in the chat box. Okay, good. So this is about the sampling, or you can also directly see. Understanding is more easy than just remembering this particular table, right? So just try to remember, understand the meaning or understand the concept and the formula, and you can easily able to recall it from time to time. Next, sampling. The size of a submitted sample in case of GOT differs from crop to crop. So I have one shortcut here. It is called as CGMS and similar size crops, WPS and similar size crops. And next it is just the beta for 250 grams and 100 grams is for bajra and jute for and of all other genera, species of that belonging to all other genera. Okay, so this is the shortcut where CGMS is nothing but C for cotton, G for groundnut, and S for soybean, and M for maize. So this is how you can remember CGMS, WPS, beta, bajra, jute, and this is all vegetative propagated crops. For all the vegetative propagated crops, it is just 250 tubers or planting stalks or roots or combs. So that you can easily remember. So the problem can lie only in the 1500 grams. So just remember it as CGMS and WPS. Yes, might create some confusion, but just try to remember it as a soybean for the first place, so that this S will be always sorghum. So this is a simple way of how you can remember this particular table. Okay. Anything else? Okay. So next is about seed germination. So why do we do this germination test? To assess the planting value and to just compare the two different lots. So that is why we do the germination test. Again, the sample size is 400 seeds and source, like how, on what sample do we conduct the germination test? We can either conduct it on the pure seed percentage, or if you can also go for a bulk. From the bulk, you can just directly do the germination test if the purity percentage is more than 98%. If it is less than 98%, then we will do it on the pure seed fraction. As I told you, the physical purity test is divided into pure seed fraction, inert material, and other crop seeds, right? So out of this, from this pure seed fraction, you take the 400 seeds and then you do the germination testing on it. So what are all the other necessary requirements, necessities that are required? So it is counting. For counting of seeds, we can do it by hand, or you can also use counting board. And this is for medium and bold seeds, counting board for medium and bold seeds, and large seeds. Large seeds includes maize, peas, beans, and etc. And now we also have the vacuum seed counter. Usually earlier the counting was even done in the hand, but we can use the vacuum seed counter for counting the seeds, number of seeds. This is a vacuum counter. Again, it has limitations where only the free flowing smooth seeds can be used for vacuum counter, not for any other seeds. And next we require a seed germinator, where we'll just keep for germination. So germination can be of different types, like cabinet type of seed germinator, for which has a capacity from 8 degrees Celsius to 40 degrees Celsius. And we have a walk-in germinator. I hope like you have already seen the walk-in germinator, if not in your universities, at least through the internet, right? So this is the two different types of germinators that are being used. So next, substrate. So what are the substrates that are usually used for germination? So we cannot use the soil directly. So we can, in the laboratory conditions, we do not have the soil, or we can also use the soil only in the pot, not on the land. So firstly, it is more convenient way is to use the filter paper, or also called as blotter papers. So out of these blotter papers or the filter papers, it is again divided into top of the paper, where on the Petri plate, 2 layers or the 1 or 2 layers of the papers are set, and above which the seeds are arranged, and this Petri plate is closed. So this is watered, and then it is closed, and this is how the top of the paper works. And the between paper is like one sheet is spread and the seeds are kept on it, and above it another sheet is spread, and we will either roll it, or it will either place it as a flat. So this is the between paper. And we have the other case called as pleated paper, where in the similar manner, like just like a between paper, we will just fix it with 2 layers. After this, we will just bend this in an alternative way. So that is what pleated paper means. So these are the 3 different types. of methods usually used. And these are the materials, like creepcraft paper, sunlit paper, sonar, or Wattman paper. I hope like you have heard about the Wattman filter paper. So that is usually, this is more generally used for germination test. And next we also have a other substrate, which is sand and soil. But this, whenever we use the soil, its reuse is not recommended, as it creates a, because of certain nutrients, fertilizers that can be there in this soil or the microorganisms, it will generate or cause the greater variations between the results. That is why it is usually not recommended to do it on the soil, but it when we do not have any other facility, we'll go for the soil. So other thing is, whenever like it will produce some phytotoxic symptoms when it is germinated on the paper or on the sand, then only we will use the soil as a substrate. The spacing, you don't have to worry about it. So phytotoxicity. So if you want to test the phytotoxicity of the substrate or the paper, if I just give you one brand of paper and ask you whether, just tell me like whether this is clean or it is phytotoxic. So how to do it? So for doing this particular process, like this testing, we use certain crops as a representative one, which are very easy and convenient to detect the phytotoxicity if they are present in the paper. So for those purpose, these are the crops, representative crops, which are used, which will give the visible symptoms on the paper, so that we can immediately decide whether the paper which we are using is phytotoxic or clean. And the pH, you know that pH can be tested by the litmus paper or directly the pH meter, and germination should be always connected in a neutral pH. So this was for environment conditions, and these are the different conditions that will affect the germination. Okay. You have another question here? You can just try to answer this, or I already answered it. Okay, no problem. So this, I think I have already showed you this particular table, right? Where I have simplified the germination percentage of different crops. See, in the above part, they are not directly asking you the percentage. They are saying that in some of the following crops, viability of the seed is very poor. Hence, the minimum germination of the seeds required for certification 70%. So they are asking for what crops germination is 70%, though they are not asking it directly, they are asking in a different way. They just talked about the viability and try to confuse people, and then they are coming back to the germination. So the germination is 70% for which all crops? Rice, what is the germination percentage? Hybrid maize, it is 90%. So what is germination percentage of C and D and E? If you just refer the table, I think for rice it is 70, 80. Yes, it is 80. And it is 75 for sorghum. And what else was there? 90, maize was 90. Next it was soybean and ground. What about sunflower? Where is sunflower? Yeah, sunflower is also 70%. So this is wrongly given, like it should be included, sunflower should also be included here in this particular statement. This was according to the IMSES. This particular table, I have made it from IMSES only. There might be some mistake in this option. So it is C, D, and E. Soybean, groundnut, and sunflower have the certification standards of minimum of 70%. Okay. I think they have provided the grace marks for that particular question. I'm not sure about it, but it's usually 70 for sunflower, castor, groundnut, soybean. The information is accurate. I don't have any doubt on it. Next, germination evaluation. Now we have talked about the germination. We have kept it for germination. Once the radical emergence takes place, there are the different categories of how they are divided. They are majorly divided into normal seedlings, abnormal seedlings, and dead seedlings. Like dead seedlings, like we have other categories like FUS, like fresh ungerminated seeds, and hard seeds. Okay, in which these two are very much important. Abnormal seedlings, whether if it is damaged, decayed, or deformed, they are considered as abnormal seeds. Normal seedlings, if they're intact, seedlings with only slight defects, and if they are with the only secondary infection, they are considered as normal seedlings. And these are counted as normal to give the germination percentage. Okay, so art seeds, they won't germinate, they will be hard and they won't be imbibing. So fresh ungerminated seeds and the hard seeds. Like what might be the reasons that these fresh ungerminated seeds, like for the presence of these fresh ungerminated seeds, why they are not germinating, and what is the difference between hard seeds and the fresh ungerminated seeds? The hard seeds, the imbibition will not occur at all, right? Imbibition doesn't occur at all. But what about these fresh ungerminated seeds? Even though imbibition has occurred, there is no germination. What might be the possible reason? Huh? Yes.
Seed dormancy.
Yes, it is because of seed dormancy. So if anyone asks you, okay, Rahul is asking about the examples for top of the paper, between paper and pleated paper. See, if I was a student, last year student, where they are asked about the method, like I was not, if I was a student, I would be not able to answer it because it is a crop specific. I will just provide you the table for the different crops where it is not following specific pattern. It's not like cereals will follow top of the paper, pulses will follow pleated paper. It's not like that. It's completely random. So it's very hard for us to remember each and every crop. I don't know like if there are any specific pattern on it, but as per my knowledge, there is nothing like that. Okay. So I'll just provide you the list. You can go through it list if you want it. Coming back, I was talking about, yes, art seeds. So next we also have the empty seeds, embryoless seeds, and insect damaged seeds. So these type of categories can be directly detected by using the X-rays. When the X-rays are employed into the seeds, you can easily see whether if they are empty. Like if there is nothing inside, like if the embryo is not at all present, we can directly see it or detect it to the X-ray or the cutting test. We can just cut the seeds and we can just see the embryo in the microscopes. So this is how they are detected. So I was just asking you one question. Okay. So what are the methods to detect the dormancy in the seeds, if there are any? So if I give you the handful of seeds, and if I tell you like tell me whether these seeds are dormant or not, or how to detect it, or if I ask you like what test procedure you will follow to know whether these particular seeds have the dormancy or not. So what is the test that you will follow? Yes, germination test. Okay. Anything else?
So at first, if we do viability, then we will be knowing that it is live or not, and then we should go for germination test.
Why dormant seeds are not live? Dormant seeds will be anyhow live only. They are not dead seeds. You can also see.
Yes, sir, they are live, but
Yes. Okay. Don't complicate yourself. It is just a germination test of how you can detect the dormancy. Nothing complicates. Okay. So it's a germination test. Just try to remember, because they might ask you in the exam like the dormancy is detected by which of the following tests. So they might give the name of a test that you are not aware of, and they also give the germination test, but you skip the germination test and think of any some other options. Since you are very familiar with the germination test and you know it why it is done, you might skip this option. So to remember that this is also used to detect the dormancy, germination test. This is the only option. So if you want to know whether the seeds are dormant or not, you just need to sow it and germinate. Try to see whether they are germinating or not. Okay. So what are the different methods to improve the germination? You can break the physiological dormancy and pre-chilling storage. Okay, these are fine. You can just go through it. Methods to removing the inhibitors. There are inhibitor substance. You can remove it for pre-washing and by removal of the structures and also disinfection of the seeds. So this is particularly done in case of certain crops. What are the methods to remove the hard seedness? So one is by just soaking for 28 to 24 to 48 hours. The seed coat can rupture and it can loosen. So that is how the hard seeds can imbibe the water. If they are continuously provided for longer period with the water, it will slowly imbibe the water. So this is just a soaking. And we also go for scarification just by piercing or clipping or filing, or sand piercing. We can also use this rough surface to just pierce this seed coat, so that there will be a scratching action which will remove the seed coat inhibitors or the hard seededness. Next, we also have the acid for scarification, which where we generally use sulfuric acid or HNO3, nitric acid for the scarification. This is the acid scarification. These are the things which we use for generally use for breaking the dormancy and also for methods to remove the RC deadness. Next is about the viability. So there are only two viability tests, which is the embryo excision test, where we will just excise the embryo and see. And the first one is tetrazolim test, where we will just stain the seeds and just look for the live seeds, whether the seeds are live or dead, right? So the for tetrazolim on the embryo excision test, the working sample is just 100:4 application recommended by ISTA. The principle is the colorless tetrazolim salt, if imbibed by the seeds, if they have the if they are respiring, they will accept the hydrogen from the dehydrogenase enzyme. So it will undergo dehydrogenations, which will convert the salt into red, stable, non-diffusible substance, which is called as triphenyl formation. So this colorless salt is converted into triphenyl formation only because of the activity of dehydrogenase enzyme. If it is active in the cell, if there is any enzyme activity, only then you will see the change in the color or the staining. Okay, if the embryo is stained, not like the complete seed will be stained, only the part of the seed will be stained where the embryo is present. If that is stained, it means that okay, the seeds are live seeds and they are viable. I also given the reaction, and this is how the stainings look like. So this is the complete staining has been done, where it is abnormal or non-viable seeds are also there in the lot, and this is complete dead seeds where there is no staining at all. Okay, Nanda is saying that we can decide whether the top of the paper method on between paper based on the seed size. Like in a maize, we cannot follow the top of the method. We should be between the paper method. So it's not like that, because I also thought in the same way earlier. But see, in the rice, I just worked in the rice in my MSc program. So I just worked in the rice, and I had a dormancy testing and a germination testing. So we generally do it in a top of the paper method only. So we use the Petri plates, in which we will just give the 2 layers of the blotter paper, on which we will arrange the seeds, and this is how we do the testing. And if you're talking about the size, usually the soybean seeds, like you have seen it, right? So they are bigger in size. Even then, we use the between paper method and roll it, and this is how the germination test is conducted in that particular crop. I don't think it is based on size. It might be you people have done it like that, but it's not universal, because while we are doing the research, we do not follow it. Usually, even though rice seeds are small, we still use the top of the paper method, and also for soybean, even if the seed size is very big, we use the between paper method for that. I actually thought of it, but this is not true for us. Okay, let me just discuss with my seniors and or scientists, and we'll just get back to you. This particular thing has skipped out of my mind. Otherwise, I would have asked it. Since our classes are online from past 4 months, I have not met anyone. Otherwise, I would be able to ask this question to my scientist already. Okay, the reaction. This is the reaction. Fine. So the compound. This is the triphenyl salt and the formazine, because of the accepting 2 hydrogen atoms, where the hydrogenation takes place because of the enzyme dehydrogenase. And whether we can use this tetrazolim test for detecting the vigor, or it is specific to the viability. Yes, like whether do we use this tetrazolim test only to detect only for viability, or it can be used for vigor test also. Yeah, based on the intensity of the color, we can classify the seed lot into highly vigorous, medium vigorous, and low vigorous. We can make the n number of fraction out of it based on the intensity of the color. So the intensity of the color literally means because it is mainly because of the enzyme activity. If the enzyme activity is high, then you will give it will give the intense color, intense red color. If the color of the if the color is dim or dull, it means that enzyme activity is less, right? If it is completely colorless, then obviously there is no activity. So based on that, we can we can classify the seeds, and once we classify it, highly vigorous seeds are those which have high intensity of the red color. Okay, so in the exam, if they ask you like tetrazolim test is used to find or detect the viability, vigor, both A and B, it's always both A and B. Don't get confused and just give the viability. It is both A and B. Okay, so other things you don't have to worry about it, just return it. Photography. Okay, so okay, detection of mechanical damage. So if there are any mechanical damage, it can be directly detected by using the solution, which is ferric chloride solution, the 20% of solution. So this is particularly for legume seeds. This will turn black if there is any membrane rupture. So see, mechanical damage itself means that there will be rupture in the membrane, like outer seed coat might be ruptured. If there is any rupture, so if it is treated with the ferric chloride solution or a test, it will turn black in color. Okay, so this is done traditionally, where it will provide the farmer or various men for the quick estimation of the abnormalities in his crop, if there are any physical or the mechanical damage that is there or not. Next is about vigor test. So the term vigor was given by Frank. And what is the objective of germination? Objective of germination, like what is the objective? Like it is objective is to evaluate the stand plant potential, like a stand producing potential of the seed lots. But so germination, since they are always conducted in the favorable conditions, we do not get to assess the real value of the plant, because if we do the germination testing in the laboratory conditions, we get a good germination percentage, but we cannot assure that when we just sow the same seed lot in the field, we will get the same germination percentage. This is because of the things like the field conditions are not always ideal, but the lab conditions are always ideal. For this purpose, the vigor concept came, where the vigor is a better parameter to detect the planting value of the seeds. Okay, so vigor test point of view, fine. So vigor testing, it was introduced by the Frederick Nobe, and it was in the 1876 only. And the term called as type fact, it was from their German language, which is called as a driving force or a shooting strength. The term vigor was introduced, and this was later it's Iltner who gave the brick gravel test for the cereal seeds. So this is one of the vigor test. So if I ask you like, okay, brick gravel test, so for what parameter we are going to do this brick gravel test? So it is always the vigor. Just remember Iltner test or the brick gravel test. It is also called as Iltner test or brick gravel test to assess the vigor of the seed lot. So brick, the term itself says that you will just put 2 mm, around 2 mm of thickness of bricks, below which you will sow the seeds. If they are able to penetrate these bricks and come out, and if they emerge the radical and they are showing the seedling growth, then it is considered as highly vigorous seeds. So this is a simple test because of the using the stones or the bricks. A test is done where if the seedlings can come out, breaking this or moving away these bricks that are closing it, so then it is considered as highly vigorous seeds, or closing or blocking them. So next we have Lacon test. Lacon gave the tetrazolim test, I told you already, and there are certain factors that are influence the seed vigor, not to worry about it. Next is star recommendation. So this would be very, very important for you to remember. So there are total of 6, or now it is 5 star recommended vigor test. One is radical emergence test, electrical conductivity test, accelerated aging test, controlled deterioration CD test, and tetrazolim test. So out of these 5, it is very specific to the certain crops. So try to remember the crops. So in the electrical conductivity test, it is 5 crops, and for radical emergence, it is 4. And next it is each have one for all other tests. So I'll just repeat it. It's radical emergent test, electrical conductivity test, acceleration aging test, controlled deterioration test, and tetraazolium test. Apart from this ISTA recommended test, we also have several other vigor tests. So that you will see in most of the model papers. They will ask you like, okay, cool test is common for, or cool test is used for which crop, cold test is used for which crop. So these are certain common questions that you will encounter. So these are all there in this direct and indirect test. So brick gravel, paper piercing, AT, and cold test. Okay. So is there anything? Cool test, enzyme, which is GADA test, respiration RQ test, electrical conductivity EC, exhaustion test, and it is again the T set. So there is a classification called as direct and indirect test, where direct tests are those direct tests are those where we will just give the conditions, or we will just give the stress to the seed itself directly. We will provide the stress to the seeds and we will see whether they are able to survive or not. But in case of indirect stress, we will just measure the physiological attributes of the test. We will not give direct stress to it. Just see what are the physiological changes that are occurring in the seeds. Okay, so this is the difference between direct test and the indirect test. So paper piercing is one of the same thing, where the seeds are sown and above it papers are kept. If it can pierce the paper and come out seedlings, then they are highly vigorous. This is how they are considered. There are two formulas, two index, which is called as vigor index 1 and 2. Vigor index 1 is calculated by using the length, seedling length, how long the seedlings are growing. Based on that, we can assess the vigor. It is called as vigor index 1, that is mean seedling length into germination percentage, and vigor index 2, it is based on the dry weight. The seedling dry weight we use to assess the vigor. Okay, they might ask you directly the formula for these two different vigor index. Okay, just try to remember them. Limitations of vigor test. Okay, this is there are again some limitations of the vigor test, where it won't predict the field emergence. Neither the standard germination will do, nor this vigor test will do. But it is better than the germination test to assess the field conditions, since highly vigorous seeds will be always show the better performance in the field. So we can do it, like we can replace this germination test with the vigor test. Next is about seed moisture content. I told you hot air woven method, right? So the seed moisture content, as per the ISTA recommendation, it is the hot air woven method which is usually followed. Nowadays, like even the research and even in the seed testing laboratories, we follow the hot air woven methods to test the seed moisture content. So there are again certain classification where there are reference methods where to establish or develop the new methods. These two different methods are used as a reference. Based on the comparing the results of these two methods with that one, like the new one which is to be developed, the new one will be developed. Like new one which is to be developed will have the assessment based on the reference which is used by this phosphorus pentoxide and Karl-Fischer method, out of which both are most accurate, and somewhere it is given that this is accurate and somewhere this is given as this is accurate. Just consider that these both are most accurate, that is why they are used as a reference method. And then we have a routine method, which I told you, it is the hot air woven method. And there are several other methods like calcium carbide reaction. Based on that, we will assess the moisture, infrared, the moisture meter, digital moisture meters. Relative humidity method is also there, like NMR, like nuclear magnetic resonance methods is used. And nowadays we also use the electric moisture meters, but these are not that accurate. So that is the reason we still use the hot air woven method for detection of the moisture content. Okay, so there are two different things where there is a part called as grinding. So the grinding is very much necessary if the size of the seeds is large. If the size of a seeds is large, they should be grinded well before the estimation of the moisture content. And for that is the reason the submitted sample is differing here. For the grinded seeds, the submitted sample is 100 gram. For other seeds, it is 50 grams. So try to remember this. And for the working sample depends on the diameter of the lid. If we are using the odd type oven method, it's a lid that we will usually use. So the diameter of the lid will decide the how many grams we are taking. If it is less than, like more than 5 and less than 8, it is 4 to 5 gram. If it is more than or equal to 8, it is always 10 gram. It can be vary from 1 gram to 0.5 gram, but it is always weighed for 3 decimal places for accuracy. This is the standard method by the ISTA. Again, in the odd air one method, so this is important. You can expect this question where they will ask you the low temperature constant method, high temperature constant method. What is the temperature? The low constant is 103 degrees Celsius for 17 hours and 134 2 to 4 hours. And generally we use low temperature for, high temperature for cereals, that is for 2 hours in case of 130 degrees Celsius, and maize is for 4 hours. Generally for all cereals, it is 2 hours at 130 degrees Celsius. For maize, it is 4 hours. Oil seeds, it is 17 hours, that is low temperature constant method. So why? Since it has high oil content, if we just directly suddenly increase the temperature, there will be membrane rupture or the lipid peroxidation takes place. There are certain new concepts. Don't worry about it. Please tell about the per millet. So what should I tell about the per millet? Like which method is employed? You're asking like which hot air warm method we use in the per millet. This is what you're asking. Temperature. Okay, whether it is high temperature or low temperature. Generally, cereals we use high temperature only, like ITCM. You have seen that they are using low temperature in which book? If it is, you have seen that, it's wrong. It's high temperature only for cereals. Its only exception is the maize, where you use the 4 hours. That is for the same temperature. Then there is no temperature difference. So, so this is a desiccant. So I hope like you know understand the meaning of desiccant. So desiccant are those which will be always given. If you just buy any new things, you will get a small packet which is written it as desiccant. It is just to avoid the moisture accumulation. It will dry up the area. That is what the use of desiccant is. So usually the desiccants are like chemicals which are phosphorus pentoxide, activated alumina, or molecular sieves. Like there are certain category which is called as molecular sieves type 4A, and this is the figure for it. And this is the mineral like zeolite. This is made up of zeolite mineral. Desiccation, why it is important? To make sure that the surrounding moisture is not accumulated around the seeds. That is why we use the desiccator for the accurate moisture estimation. Why? Because once we just put the seeds in the hot air oven, once we remove it, like even after removing the seeds, because of the relative humidity in the surrounding area, the moisture can come and accumulate on the seeds. So that is the reason we use the desiccator or desiccants. Grinding, okay, not to worry. Grinding again, for the moisture estimation, we have one and two stages. If the moisture is at the very first place, if the moisture is low, then we will use the only one stage estimation. If there is a high moisture content, we have to decrease that moisture content to certain level, and then we have to estimate the moisture. So that is why it is a two-step process. And if it is for the moisture content which is more than 17, in case of soybean or in case of oil seeds, and it is for more than 13% for cereals. If the moisture content is for 13%, more than 30% in cereals, we go for two-stage determination. And also for all the crops which require grinding, because of the bigger size, there will be obviously higher moisture content, and we go for two-step process. I have one question, I think. Yeah. So can you just read out the question and just answer it? This is based on the concept that I have just explained you now. This was asked in JRF 2022. The marked answer is correct or it is wrong? Okay, correct. So this is based on the thing I explained you that for the moisture estimation by auto method, fine grinding. Again, in the grinding, there are two different methods. One is fine grinding and coarse grinding. So this is also compulsory for some crops. So why? What is the reason? The bigger the seed size, they will fail to completely expel all the moisture from the inner tissue. That is why the grinding becomes necessary for it. Next, there is another question which is they are asked for specifically for pigeon pea seeds. So I told you it is for 2 hours for 130 degrees Celsius for cereals, and it is for maize, and this is common for pulses. And for the oil seeds, it is 103 degrees Celsius for 17 hours. Okay, just try to remember them. So for the cereals, it is 130 for 2 hours, and it is this is not maize, like this should be 130 for 4 hours in case of maize, and this is 130 for 1 hour in case of pulses, and for 103 for 17 hours in case of oil seeds. Okay, so that next we have seedal testing. I don't think like there is any necessity that I have to cover this because this is already covered in the pathology. So I have just give the document so that you can read by yourself. So this is only consists of 2 different slides. So just go through the document, and we do not till now we do not employ or we have not adopted any seedal testing in general. I already told you like the routine test. Routine test also doesn't include any seedal test. Even when we go for seed testing, we do not do it. Like this is assessment, we don't do it in the seeds. This is not even in the standards. So in the recent days, like the procedures are evolving and they are just incorporating the procedures, and they are making the manuals. In the meantime, I think in the near future, they will also we'll also get some standards for all the different crops for this seedal test. But for as of now, we don't have that standards. We have procedures, we have everything, but it is not compulsory that it should be done for certification for till now. I hope that these things are clear. So we have completed our CTech part in 16 sessions. I know like I might have rushed it in last 3 to 4 classes. The only reason being that I have to cover lot many contents, and also like if I just go and keep on explaining the little things, it might bore you. So that is why I just keep the major things, and because this is from the feedback that I have received from the students that you only focus on things that we do not know. That would keep up the interest of the students. So this is why I've just rushed out. But if you have any particular doubts in any of the topics that I have covered, not even if I have not covered it, you can always ask me in the through the WhatsApp or the phone call. Anything is fine. Just be motivated and just be prepared for everything. You might expect your exams within next week, next month, like at least by the July end. So don't leave your preparation now. Just make sure that whatever you have prepared till now, like it will matter, but what we will do prepare now will matters a lot, because it's a revision that will matter a lot at the end. It's not like how many from how many months that you have prepared. It's about the revision, like how many times you have revised now, and how much you are clear about the concept that you are already learned and understood. So make sure to do it. And in my next class, I will just wind up in 10 to 15 minutes, taking up the primary samples. Sir, seed replacement ratio used in seed demand forecast. I do not, I'm not sure about it. I have to check it, whether they will use this in the demand forecast or not. Seed replacement rate. You're asking about a multiplication ratio or just a seed replacement rate only? Because I have seen the revised schedule for the multiplication ratio, but I have not seen it for SRR. I have to check it. I'll just check it and tell you, okay? For seed demand forecast. Yes. So you can always post it, like even you can always ask your doubts through the WhatsApp. Okay, just make sure to do it and take a full benefit of what we are providing you, so that you will get a good fruitful result in the exam. I hope like the things are very clear. I can assure you one thing: if you have attended all the CTech classes, I can bet you that you will be more clear or most clear about the concepts than any other people who have done their self-study. That is for sure. Because as of now, I can see the difference in me when I was preparing for the JRF, and I have also referred so many books for CTech, even for CTech, just to attend 8 to 10 questions, I have just referred 2-3 books. So even though after those multiple readings, I was not clear about many concepts, but the understanding that I have and I have given you, that is more than sufficient and it will definitely help you in the exam. So make sure to revise the things which I have provided you, the notes that I have given. Don't neglect anything. Even sometimes you might have felt bored in attending the sessions, but make sure to take full benefit that what I am providing. Like I myself spent over past 4 months, 5 months from December 21st. Like I just started preparing the notes from December 1st itself. Like I started preparing the notes. I also prepared with you people for this JRF. So till now it is March 25, and it's already the month end. So I spent around 6 months just to prepare the notes. So it's very, like, it was very hectic for me too. So just take a full benefit out of it. Just download it. Don't neglect anything, any part. Just make sure to focus on the things that I have told you, that these are very much important, because they will definitely come in the exam. One or the other way. Okay. So just revise the things and don't lose the focus. Since it is only 1 or 2 months left, don't lose your focus. Just make sure to revise the things from time to time. And now, if you are not feeling confident about any concept that you had learned before, don't try to spend so much of time on that. It's fine now. Till now, it's fine. At least before the month, stop practicing all these things. Make sure that you just revise the things that you have already understood. For another 15 to 20 days, it's fine, you can do it, but after that, just try to revise the things and make it organized the way you are revising the things. It's not like very random that you in the morning you revise some subject, and the evening you revise the other, and the very next day you do it in another way. Don't do like that. Make a proper schedule once you start your revision. Okay, so I have so many things to say, but this has become a lengthy session. Once again, after some days, we can just again have an online meet, and where we can discuss some things. Okay, so thanks for attending. We'll meet in the next class.